Hello and welcome to this video tutorial. Today we're going to look at Unit 2, Lesson 1, Introduction to Functions. We're going to look at the fluency section, applications, and reasoning. So let's take a moment to first redefine what makes a function. So a function is such that every input, every number that you input, everything that you input has exactly one output. Meaning you're never going to have two different inputs get the same output. Okay, so one input for one output. That's really what defines a function. So in question number 1 here, it says decide whether each of the following is a relation. Define whether each of the following relations is a function. Explain the reasoning. So the input is states, the output is capital. So we got to think, well, the output is exactly, there's only one capital in each state. So yes, that would be a function. Because each state has one capital. Okay, how about states and cities? Well, does each state have only one city? Remember, input to output. Every input has only one output, right? Does each state have only one city? No. That would not be a function because each state has many cities. Okay, families and pets. Well, does each family have only one pet? Not necessarily. Some families have many pets, right? That's not one input for one output. Okay, and how about families with last names? Well, for the most part, yes. I mean, I know we do have some hyphenated last names, but, for the most part, yes, each family does have one last name. Okay, so that's really where we're kind of trying to define. Now, in number 2, we're taking a look at the following examples using an input-output chart to decide if each of the following relations is a function. So in part A, consider the following relation. Multiply the input by 5 and then subtract 7. So input by 5, so 5 times the input, subtract 7. This is what we're going to do and to get an output. So I'm going to put in here, I'm going to go 5 times -3, that's the input, right? Minus 7. Well, in here I get what? -15 minus 7 is -22 is the output. Okay. All right, so now I'm going to plug in 5. I'm going to plug in 0 for the input. So we're going to go 5 times 0 is 0 minus 7 is -7. And then for the last one, I'm going to go 5 times 6 minus 7. Well, 5 times 6 is 30. 30 minus 7, right? So we're going to go 30 minus 7. That would be 23. So here, is this a function? Well, each input has its own output. So yes, that is a function. Okay, now let's consider this right here. No calculation needed per se, but let's look at this. If the input is 2, we get an output of 4. Okay, -2, excuse me. Input of -2, output of 4. Input of 3, output of 3. Input of 3, output of 2. Well, wait a minute. How can an input have different outputs? Well, for a function, it can't. That would not be a function. Because here you have this input of 3 doesn't have one output. It has more than one output. Therefore, it's not a function. Okay, we're going to do the same thing graphically. Okay, so input, so -2. So if I go over to -2, that's here, and if I go up to the graph, that would be this point right there. Okay, you could say that corresponds pretty close, I think, to probably y equals 4. It's very close. I'll call it y equals 4. Okay, at 1, at x equals 1, which is right here, go up to the graph. Looks like y equals 1 right there. And then same thing, if x equals 2, I'll go up, y equals 4. So does every input have its own output? Yes. That is a function. Okay, so if I look at this here, -3, well, that puts me about right there. Okay, that would be an output of about 1. If I go to 1, that's right here, and if you look at x equals 1, you have an output here and here, which is at about 2 and 7. And then at 3, you have an output here, here, and here. We have 3 outputs at about 3, looks like 4 and 8. So in other words, you have 2 inputs that have multiple outputs. No, not a function. All right, so in our application question, we have a situation where we have a person, a pizza delivery person. So Andrew has a new job at a local pizza shop as a delivery boy. The following graph shows one of the deliveries he made. Analyze the graph and answer the following questions. So the graph, if you can see on the y-axis, is distance from the pizza store in blocks. So this is distance in blocks. And this is the time spent driving in minutes. So how long was the entire trip? Okay, well, if you look at what happened, you can see that he went in the first 2 seconds, analyze each line segment. Okay, so in this line segment, he went a total of 5. Okay, oh, I'm sorry. How long was the entire trip? That indicates time, not distance. I'm sorry. Looks like the time starts at 0, ends at 15. The entire trip took 15 minutes. If he arrived at the house after 4 minutes, how far away was the house from the pizza place? So let's take a look at 4 minutes. So here's 1, 2, 3, there's 4 minutes. Go up to the graph, that's right here. So how many blocks away from the pizza shop is that? Well, that input of 4 minutes has one output, 9 blocks. So we're analyzing the graph for the information using input-output because this represents a function. Now, why might Andrew have stopped 3 times for 1 minute? Well, if you look at 2 seconds, he stopped at 5 blocks for 1 minute. He stopped here. He stopped here for 1 minute, between 9 and 10 minutes. And between 11 and 12 minutes, he stopped as well. So why might he have stopped? What in real life could have caused him to stop for exactly 1 minute? Possibly stoplights? Maybe hit a red light? I mean, that's what makes sense to me. Now, was Andrew's trip longer going to the house or coming back? Now, longer, we're talking about time, mind you, okay, not distance. So if we look going to the house, so it looks like he gets to the house in 4 minutes. It looks like he spends 4 minutes at the house delivering the pizza. And then it looks like from 8 to 15 seconds, so from 0 to 4 minutes, he's going to the house. And then from 8 to 15 minutes, he's coming back. It was longer coming back. 7 minutes obviously is greater than 4 minutes. Okay. Now, given the following scenario, graph a function that would map Lisa's distance away from her house according to time elapsed. Same idea, distance from home in blocks, time elapsed in minutes. So Lisa has a few items she needs to pick up from the grocery store 8 blocks away. So you know she's going a total distance of 8 blocks away. On her way to the store, she doesn't hit any red lights. She doesn't hit any red lights, and she takes 4 minutes. So she gets to the grocery store, which is 8 blocks away. So 4 minutes, 8 blocks. There's our first point, and that first line represents her moving 8 blocks in 4 minutes. Well, she spends 8 minutes at the grocery store and then starts to head home. So if she's at the grocery store, she's not going to or from her home. She's at the same distance away from her home. So 8 minutes away would put it at 4 to 8, 12. So find 12 minutes, and that would be the time she spends at the grocery store. Okay, and then it says that when she's halfway home, so you got to remember the store is 8 blocks away, so halfway home would be 4 blocks, right? So when she's halfway home, she hits a red light that lasts 3 minutes. So she's headed home at the same rate, mind you. So it's the same steepness of line here, but the red light lasts for 3 minutes, so she hasn't moved anywhere for 3 minutes. So that would put it all the way up to 17 minutes. Okay, after the light ends, she then drives the second half of the way home, and it would be at the same rate, so the same steepness of line. Notice how the steepness of line here, the rate at which she's traveling, is the same rate at which she's going home. Hence, the steepness is the same. Now, in a physical science perspective, we call distance divided by time speed. So this slope that I'm highlighting here actually represents the fact that she's going the same rate or the same speed at 2 blocks per minute. That's what's told us right there, 2 blocks per minute. So every 2 blocks for every minute is the rate she's moving to and from the store. I hope you found this tutorial to be helpful. See you next time.